Okay, so we'll cross that out since I don't need it. These are basically, it's just like algebra essentially. We're just plugging in our variables. So we're going to do -2, and instead of plugging in a u, we're going to plug in -5 comma 2, and we're going to do plus our -1 comma -3. Distribute everything. I'm going to use a different color. I don't like this yellow. I get 10 comma -2 plus -1 comma -3. If I combine this, I get a 9 comma -5. And oh shoot, this will be -4 because 2 times 2 is 4. Come on, Victor. I blame, but that would be make this 11, which would be wrong, Garrett. Wow. All right, so that's all you do for that one. The next one, again, all we're doing is just plugging stuff in. So we're going to do 3v. So now we're doing v. So it's -1 comma -3 minus 3. This is 3 comma -4. Distribute this out. We get -3 comma -9. And this is going to be, we're going to put a plus sign kind of as a placeholder. -9 comma +12. I guess I don't need to put a positive there. 12. Combine these out. So we get -12. And what happened here? Oh, there is a negative there. I was like, they make it so small, or am I just blind? Both? Okay. They make it small and I'm blind? Okay. So that's how we get that one. The next one, they try to make it seem all hard, but it's not that bad. We're literally doing the same thing. -5 comma 2 minus parentheses, what was it? -1 comma -3 plus 2. Our W is 3 comma -4. I have no idea where he is. That dude's asleep. He's probably, he's like, I finished my test and it was like 9 o'clock. I'm like, yeah, I wasn't gonna answer that. I've been wanting to fall asleep at 7, but then I'm like, it's too early. But I should probably start sleeping at 7. But I think waking up a lot at night, if you're waking up at 7, it's kind of relaxing because you're like, oh, I'm up, but I can just go back to sleep. Uh, so what I'm doing here, guys, is I'm just combining. I combined the first two, then I have to combine the next two, obviously. So that's going to give me a +2 because it's 4 negatives and 6 positives. So my only answer could be this one. So by process of elimination, this has to be my last answer. And that makes sense because this is -10. And if we distribute the -4 to that W, that's -12. So that gives us that -20. So there we go. All right, so moving on to the next one. So just basically, think of addition and subtraction. It's the same thing we did with the other things. We're just using two variables now. We're using our y variable and our x variables. The next thing we have to deal with is this thing called unit vectors. So a vector u is a unit vector in the direction. So unit vectors are just kind of, how can I explain this? They just, well, they're what it is. It's a unit. So a unit just means that they're exactly one long. Think of the unit circle. Its radius is one. A unit vector has a distance of one. So even so, the very basic unit vectors you can think of are basically 0 comma 1 or 1 comma 0. These are very obvious unit vectors, but as you can see here, this 1 to the negative 4, um, first of all, it's not a unit vector. So if you want to make it a unit vector, you're going to have to, whatchamacallit, did you multiply this? Why are we talking about multiplication? Basically, this is just saying, like, try to make this equal to 1. So unit vector multiplication magnitude 1. Let's this to verify the magnitude of 1. Okay. So if you want to make something a unit vector, it's just saying, like, hey, just multiply it by its distance. We're just making it equal to 1. So we're doing the distance over the other distance, basically. All right, so let's take a look at these. So this is what I was talking about with the basic unit vectors. Um, we're going to use I. I is going to represent basically our x movement. And J represents our y movement. What are you clicking on so much, Garrett? So, well, you keep going click, 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 click. So, what? No, I'm good. I'm good. So basically, when we're talking about these types of unit vectors, I don't know what was this slide about. Like, oh yeah, the distance is just basically unit vectors have a distance of 1. I don't know why they did all that complicated stuff. It's kind of weird. Um, the main unit vectors that we're going to be familiar with are J, which is our Y movement, and I, which is our X movement. And if we do negatives, that's going to determine the other directions. So any vector can be changed with unit vectors. So let's say we have the vector, where is it? Negative 2, 5. That's essentially the same thing as saying negative 2i plus 5j. They have it. Why are they multiplying it? Oh, they also want to do the combination to make it the length of a unit. Oh, I see. I don't know what they're doing here. They're doing weird stuff. Oh, they're combining the vectors. They put too many words in here. I'm sorry, guys. And then I don't like reading, so I never read the whole thing. So basically, if they want to do this vector here, they're just going to call it I and that. That way, we can use variables instead of having to use these weird less than and greater than signs. All right, so going to the next one. So if we look at these vectors, we're going to see what happens when we're talking about subtraction. So if we look at this, this is my 4v minus 3v. So if this is our 4v, it's our minus v. You can perform vector operations such as addition and scalar multiplication. So here's a scalar. Then we're going to go down 3v. And that's the exact same thing as subtracting it. So if we do something like we're going to go over 4v and then we're going to go down 3v, this terminal point right here would be the same thing as if we're like, what if we just combine the two vectors together? Well, then we have this vector right here instead of two different vectors, and they still have the same terminal point. They still end in the same spot. So that's what this is talking about here. You can multiply, subtract, and divide, and it's the same thing as traveling and adding it together. It's like, well, instead of calling it this vector minus this vector, just write the whole thing as one vector. That's all this is saying. I always find how they describe vectors weird. So if you see me like struggling with it, it's because I'm like, it's not that hard. It's just this idea that instead of, I guess so, instead of going like, I want to go this way and then this way, it's like, well, why don't you just go this way? You get to the same spot. That's essentially what it is. Instead of traveling in two different directions, it's like, why didn't you just go this way and just make it in one direction? That's all of that Jazz was saying. I feel like they make it way more complicated than it has to be. So this is saying, here's our initial point, here's our terminal point. Write the vector. All right. So remember, we're always going to do our terminal point minus our initial point. So we're going to do 8. Using our terms, we can do 8i minus negative 2i, and we can do it as minus 5j minus negative j. This is going to give me 10i. So, in other words, 10i and negative 4. I don't know why I wrote I, because they want it in vector notation. 4. I just wanted to do it with the i's just to show you guys that you can't combine i's and j's. So that's how come, that's why these are a good way of going like, hey, it's a good way to add your vectors together. What? What did I do wrong here? Terminal vector minus initial vector. It's negative 10. Terminal vector minus initial vector, that's negative 4. Oh, they did want us to put it in i's and j's. Whoops. There we go. But it's the same answer, it's just they're doing it with i's and j's. All right, so going into this one, looks like Edmentum was ahead of me on that one. So if I'm doing this, I want to do a negative initial vector. So I'm going to do a negative initial vector. This is another way of doing it. Instead of doing it as terminal minus, you're just going to change the sign of your initial. And you're going to leave the same signs for your terminal. So when you combine these, I'm going to combine I know my eyes sometimes look very similar to my J's. I'm sorry. Every time I had to turn stuff in high school, I had to be like, no, that's this letter, see? Or I would get like a red mark going like, write better. So this is true. But I have a pen, which makes this sad. So we combine this, we get negative 11j, and we're going to get positive 6 or negative 11I plus 6j. So you always want to do your initial as a negative. They do it a little differently. They don't start off with the i's. They're like, hey, do your terminal minus your initial, comma, your terminal minus your initial. All right, so let's get into this. Let me erase this. And find the unit vector in the direction this. So we need to find the unit vector. So in order to do this, we're basically doing this. I like to do it this way. I don't this idea of we need to find the length of it and then we're going to divide it out. So if I look at it this way, I'm going to go 3 on the x, negative 1 down here, and I'm going to find this length right here, right? So if I look at it that way, let's find out what this length is. So we get negative 1 squared plus 3 squared, and we're going to square root that because we want to get this c. So this becomes 1 plus 9 square root. So we end up getting this square root of 10, right? So in other words, we want to divide our x value and our y value by the square root of 10. And I probably should have shown my work for this. So you can type that in here. So show your work in here, just copy what I did basically. And then what we're going to do is we need to make everything smaller by that factor of square root of 10. So my answer will essentially be 3 divided by square root of 10, comma, negative 1 over square root of 10. What this does is it's going to shrink this by the square root of 10, making it exactly 1 long. So we have a different length here and a different length here. Probably should have used different colors. Different length here and a different length here. And that's basically what you do to make it exactly a unit long. I want to see, yep, they did the same way. I was like, I don't know if they do it any different, but yeah, they just solve for the distance and then divide by the distance. I never really understood this whole like, yeah, you do the vector times the distance. I guess it's the same thing. It's just weird to me. Just do your vector divided by the distance, and that's it. That's how you solve for this. So each component, you do your i's, then you do your j's, and that's it. So find the unit vector for this one. So again, this is the idea of the Pythagorean theorem. So we're going to go, oops, I did this wrong because it's supposed to be negative 2. I guess it doesn't matter because you end up squaring it anyways. But you would go negative 2, and then you would go up 5. So this would be negative 2 squared plus 5 squared. We're going to do square root to try to get the distance. So this ends up being the square root of 4 plus 25, which gives us the square root of 29. So this tells me that my unit vector is negative 2 divided by square root of 29, comma, 5 divided by the square root of 29. So that would be the unit vector, the exact, this tells you the same direction, it's just the, whatchamacalled, the magnitude is only 1. So going to the next one, this one's actually really easy because guess what? If you're going this way, negative 9, and you're not going up or down, guess what? Your distance is 9. from 0 to 9, -9. So this is actually really close to a unit vector. You just have to divide it by 9. So my unit vector here would be -1, comma 0. So by not having a different component, it makes it really easy to do this. And then this is basically just like, I understood it because I know the Pythagorean theorem. And yeah. All right. So, and I believe that's it. I think that's everything. So make sure you look up the summary. Again, vectors, just think of it, it's kind of like a combination of algebra and geometry. You're dealing with an x and y and how it's drawn, and you're also dealing with combining it. Later on, we will use trig combined with all this, but yep, that's pretty much it for this one.